Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating discussion about running a large language model, specifically the Deepseek R1 Distill 8 Q40 model, on a cluster of Raspberry Pi 5s. It's pretty impressive, wouldn't you say?
Absolutely. The sheer audacity of running an 8B parameter model on a bunch of relatively low-power devices is mind-blowing. So what were the key findings from this GitHub discussion?
Well, the core experiment involved benchmarking the model's performance, both evaluation and prediction speeds, using different numbers of Raspberry Pi 5s. They started with 2, then scaled up to 4. The results are quite striking.
Striking how?
With 2 Raspberry Pis, they achieved 7.70 tokens per second for evaluation and a significantly slower 3.54 tokens per second for prediction. But, when they doubled the number of Pis to 4, the evaluation speed jumped to 11.68 tokens per second, and the prediction speed improved to 6.43 tokens per second. A noticeable improvement, right?
Definitely. That's almost a linear speedup, which is excellent for a distributed system. It shows good scalability. But what's the significance of the network is closed message? Does that limit the potential performance gains?
That's a great point. It seems that the network connection between the Pis might be a bottleneck. The message appeared after each benchmark run, suggesting that the communication overhead might be impacting the overall throughput. Further optimization of the network configuration could potentially yield even better results.
I see. So while the scaling is impressive, there's still room for improvement by addressing the network limitations. It's interesting that they're using such a relatively low bandwidth network for this kind of task. Perhaps a faster network would significantly improve the performance, especially for the prediction task, which seems to be more sensitive to network latency.
Exactly. It highlights the importance of considering all aspects of the system, not just the processing power of the individual nodes. The network is a critical component in a distributed system like this. The detailed timing information provided, those millisecond measurements for each token, is also really valuable for fine-grained performance analysis. It allows for very precise identification of bottlenecks.
Absolutely. This level of detail is crucial for optimizing the system. It's a great example of how careful benchmarking and detailed logging can lead to significant performance improvements. The fact that they've shared this data so openly is also commendable. It allows others to learn from their experience and potentially replicate or improve upon their work.
You're right. Open source collaboration is key to progress in this field. And the enthusiasm in the comments section, pretty sweet, speaks volumes about the community's reaction to this achievement. It's inspiring to see what's possible with readily available hardware and clever distributed computing techniques. This is a fantastic example of pushing the boundaries of what's considered feasible.
Indeed, it's a testament to the power of open source collaboration and the ingenuity of the developers involved. Thanks for breaking down this fascinating discussion for us. This has been a really insightful look into the world of distributed large language model inference.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.